Okay, let's take a look. We're going to try to do some predicting reaction products, reactions of alkenes. Aside from burning or combustion, the only reaction that alkenes do that we will see is addition. Addition is where the double bond turns into a single bond. And the two types of addition that we have learned about are addition of H2 and addition of H2O. This is hydrogenation, this is hydration. We've learned about both of those. Now let's see how they look. We did mention that a catalyst is required. The way you know something is a catalyst is if it's written above the arrow. Sometimes, though, it's also written this way, a slash. If you see this, what this tells you is the first thing is the reactant, the second thing is the catalyst. The catalyst does not show up in the product. You can imagine it's not there when you're trying to predict the product. You know that it must be there for the reaction to happen, but to complete the reaction you can not pay attention to it. So I'm adding H2. Always what will happen is this, the double bond turns into a single bond. The rest of the molecule stays the same. So I've let the double bond turn into a single bond, and if I added hydrogen, each carbon gets an H. The carbons that used to have a double bond, one gets H, the other gets H, and that looks like this. I could write my answer like this, or if I'm using regular line angle notation, I could just keep it like this. Remember, we don't need to write the H's. Pay attention to what kinds of compounds these are so you can start noticing patterns. This is an alkene. This, as we said, is hydrogenation. Hydrogenation, and when you do that, you produce an alkane. These are the same. You produce an alkene. When you hydrogenate an alkene, what you get is an alkane. Notice you cannot hydrogenate an alkene. We cannot add H2. There's no bonds to add it to. There is no double bond. But can you hydrogenate alkene? Yes. When you hydrogenate alkene, what do you get? Alkane. How about this one? If I were to say this, complete this reaction, here's what you would say. You'd say, oh, alkene, I know what happens. The double bond will turn to a single bond. I will either be adding hydrogen or water. Looks like in this case we're adding water. What's this? If it's after the slash, this means catalyst. Sometimes the catalyst goes right here above the arrow. Sometimes it might be written like this. Either way, you say to yourself, that's the catalyst. I need it for the reaction to happen. But to write down what's the structure of the product, I don't pay any attention to it. Cover it up. It will not show up in the products. So, how do I do it? Double bond turns to a single bond. There it is. Gone. Double bond is gone. Now it's a single bond. One carbon gets the H, one carbon gets the OH. I'll write that like this. And again, I can leave my answer like that, or I can write it with just the OH showing. Like that. Those are the same, but notice, this is not alkene, it's also not alkene. This is alcohol. And the name of this reaction, as we've seen, is hydration. This helps us see when you hydrate an alkene, what you produce is alcohol. Okay, let's do these other examples. What if I say this? Complete this reaction. You would say alkene. What will happen is the double bond will turn into a single bond. Nothing else will change. And I'll use the same notation that we had for the reactant. This used to be a double bond. Now it will be a single bond. So the double bond has turned to single. We need to add one thing to each carbon. If we were hydrogenating, one carbon gets H, the other carbon gets H. Palladium is the catalyst. You know that because it's written above the arrow. So again, this was alkene. This is hydrogenation, and this is an alkene. When you hydrogenate an alkene, you produce alkene. This exact same alkene can react with water. You might not have seen this before, but you still know, oh, that's a catalyst, and you know that because it's written above the arrow. This will not be hydrogenation, we're adding water, so this will be hydration. But the reaction goes the same. We keep the molecule exactly the same, except that the double bond turns into a single bond again. Everything is the same. I think I have I've got extra carbon. Everything is the same, except my double bond here has turned into a single bond, and now there's space to add one new bond to each carbon. One carbon gets H, one carbon gets OH. And once again, we see that this is no longer alkene, it's not alkane, this is alcohol. When you hydrate an alkene, what you get is an alcohol. You cannot hydrate alcohol, it doesn't have a double bond, but alcohol is produced when you hydrate alkene. These last two will be the same. The fact that there's a ring doesn't change a thing. If we're going to hydrogenate it, let's say that looks like this, complete the reaction. Complete the reaction. The double bond will turn to a single bond. I add H and H, and if I don't want to write in the H's, I don't have to. Line angle notation, they're not there. This is hydrogenation. Again, it turned an alkene into an alkane. If we take that same alkene and add water, that's hydration. Hydration is adding water. When you hydrate an alkene, we know what happens. Everything stays the same except that the double bond turns into a single bond. Notice the ring is still a ring. Don't change that. All that changes is the double bond turns into a single bond. One carbon gets H, one carbon gets OH. The OH I do need to write. That cannot be left invisible, but the H can be invisible, just like all these H's are invisible. And that, again, helps us see, oh, look, alcohol. When you hydrate an alkene, what you get is an alcohol.